In this video, we're going to solve the 1998 AP Calculus ABFRQ question number 1. It looks like it's a solids of revolution and area question. So it says, let R be the region bounded by the x-axis and the graph of y equals root x, and the line equals x equals 4. Find the area of the region R. Okay, so let's draw this. So when you draw this, at 0, it's going to be 0. At 1, the root of 1 is 1. At 2, it's about, 1.4, 1.5, somewhere around there. At 3, we don't know, 1.7-ish. Then at 4, the root of 4 is 2. So it's going to look like this, which is a root of x. And it wants it bounded between x equals 4. And so it's this region right here. So when we find the area, this is a nice easy one. It's going to be equal to the integrand from 0 to 4 root x dx. Now, it's a little bit easier to write this as x to the 1/2. So now when we integrate this, we add 1, so you're going to get 3/2, divide by 2/3, well, divide by 3/2, which means multiply by 2/3. So this is the antiderivative. And I'll pull the 2/3 out, so now you're going to get 0 to 4. Okay, so now you have 2/3 times the quantity of 4 to the 3/2 minus 0 to the 3/2. An easier way of doing this is to make 4 into 2 squared, raised to the 3/2. These will cross out, minus 0, 0 to 3/2 is 0. So now you're going to get 2 to the 3rd is 8. 8 times 2 is 16/3. That is the area. Okay, part B says, find the value of h such that the vertical line x equals h divides the region R into two regions of equal area. So what you're going to do over here is 1/2 a equals the integral from 0 to h root x dx. So we know the area. The area is 16/3, so we're going to do 1/2 16/3 equals the integrand of this. We're going to have to do it in terms of h because you're plugging in h. So now you're going to get 2/3 h to the 3/2. So now you're going to get 8/3 equals 2/3 h to the 3/2. So now you're going to multiply both sides by 3/2, so you're going to get 24/6, which is 4, equals h to 3/2. So now I get 2 squared. I'm going to raise each side to the 2/3 power, equals h. So now I'm going to get 2 to 4/3 equals h. So now I'm going to get the cubic root of 16 is equal to h. Okay, part C. So part C says, find the volume of the solid generated if it's rotated around the x-axis. So that's easy. If you do this, it looks like it's going to be a disk. It definitely is a disk. So that's easy. The formula of that is pi r squared. So volume equals pi. The radius of this is root x, but we have to square it, dx, and the boundaries are 0 to 4. So volume is going to equal pi x dx, so the antiderivative is going to be pi, what's that, x squared over 2 from 0 to 4, which is going to equal pi, what's that, 4 squared 16 divided by 2 is 8 minus 0. So that's going to equal 8 pi. So for part D, it wants us, the vertical line x equals k divides the region R into two regions such that when these two regions are revolved about the x-axis, they generate solids with equal volumes. Find the value of k. So it's kind of the same thing as B. So we're going to do 1/2 the volume equals pi 0 to k root x quantity squared dx. So now we're going to do 1/2. What was that? 8 pi? Yeah, that was the volume below. Equals, the antiderivative of this is going to be pi. We got to plug in k, so it's k squared over 2. It's whatever this was over here. That's what I'm using. So now I'm going to get 4 pi equals pi k squared over 2 multiplied by 2. So I get 8 pi equals pi k squared. Divide by pi, 8 equals k squared. So k equals the root of 8. But it is also a calculator question, so you could write 2.828. And I hope this video helps.